Alright, so today we don't have anything specific planned. We're just supposed to look at the whatever stuff you guys have questions about. In the syllabus we're sitting right here. So we've got today and then all next week for you guys to work on the project, and then a week from Monday is when it's due. No, a week from... I guess it's a week from Wednesday because we don't have class on Labor Day. So the project's due the Wednesday after Labor Day, right? So the one thing that somebody was asking me about, those of you that haven't done that did 2610 when before I did Python, you may not be especially comfortable with the plotting with Matplotlib, and this jumps straight into doing three-dimensional plotting even. So here is a little bit of example code, and I uploaded this to D2L under Content Lectures. There's the example PCA we had last time, then there's this one, the example plot. And so this creates a three-dimensional plot, draws lines with markers on it. Okay? So you need to have the standard matplotlib.pyplot. Okay? Just like when we do NumPy, we import it as, so we don't have to type out all of that stuff every time. The NumPy, normally you import it as NP. That's what everybody does. Most everything I see online, they import that as PLT. I don't know. I personally don't like the PLT. I like to have the O in there and do the plot. So I import it as plot, but you'll see that a lot online as imported as PLT. So if you see PLT dot something, that's the same thing as my plot dot something. Then in order to do this is very much like MATLAB plotting. Okay, we'll recognize a lot of this stuff. Then you'll also have to import this axis 3D. Okay, it's interesting that it's giving me a warning that I imported it, but I didn't use it. Basically I haven't done axis 3D period something, and that's why it's saying that I haven't used it. But I need there's a class definition. We're going to be using getting axes, the class, an instance of an axis class, and that class definition is in axis 3D. So you have to do this import here, or it won't work. Okay, so then I'm using the matplotlib pyplot plot and opening figure 1. Just like you do in MATLAB, you do figure 1. Okay, and it returns an instance of the figure class. I guess we probably could see that over. Well, I guess not. Interesting. Anyway, there's an instance of the figure class here. Okay, and we're going to need that in a second. Then I'm going to clear the figure. Okay, plot.clearFigure, very much like MATLAB. And then here I'm going to call a member function of the figure class, which is GCA, which stands for Get Current Axis. Okay, again, that's a similar command that they have in MATLAB. And you need to pass to this function that you want it to be a three-dimensional projection, that you want to be a 3D plot instead of a 2D plot, because by default it'll just be 2D. Okay? Now you have this axis, the instance of the axis class, that's defined in this axis 3D, and then you can call the member functions associated with that class. And one of them is the plot function. And the way the plot function works is you pass it a list or an array of X positions, a list or array of Y positions, a list or array of Z positions. And so this is the order pair. 0, 0, 0 is the first point. 0, 0, 1 is the second point, etc. And then, just as an example, I passed a whole bunch of there's a bunch of other input arguments that you can modify. You can say the line width, so this line is thicker than it normally is. I set the color of the line as being magenta. I set the marker size to be quite large. 16 is pretty big. Okay, I set the edge color of the marker to be blue, so the outsides of the stars are blue, the face of are cyan, so you can change all these different things. And if you go on the documentation for Axis 3D, the Axis dot plot, you can see there's all sorts of different things that you can pass to that to do the formatting. Okay, then there's also member functions for setting the labels of the X, Y, and Z axis, so it says X, Y, and Z. Okay, so I think you were asking me, weren't you, about how to plot the bounding box, right? Somebody was it not you? It was somebody else. Somebody was. Kyle, maybe? I don't know. Somebody was asking me how to plot the bounding box. So this is a way that you could do that, is once you have the 8 corners of the bounding box, you just have to draw lines between all of the points in the bounding box, and you can format the lines however thickness or color or whatever you wanted for them.
So how did you get the lines to connect all the points together?
It automatically connects lines. That's how it works in MATLAB, and it's how it works in Matplotlib too, is that you give it the points, okay, and it will automatically draw a line there, okay? Now there is another line style, I think, and we can set the line style to be dotted, for example.
I thought in MATLAB we used lens space to get like large values, and then we used those, and that's what created the line.
You did use a lens space to have lots of points, but that would be so that there are many points, because right now I only have 1, 2, 3, 4, 5, 6 points. Well, actually 7, because it wraps all the way around, because the 0, 0, 0 is both in the beginning and at the end. And so, yes, in MATLAB we had used the lens space to get a lot of points, but it still drew a straight line between every point. Okay? Now in this case where I'm trying to draw straight lines. In the bounding box you're drawing straight lines. You don't need lots of points in between the corners of the bounding box, because it will draw a straight line between the points. But if you have a curve, so if you're drawing a curve in MATLAB or in Matplotlib, you do want a lens space where there's lots of points, because it will draw a straight line between every point. And if you only have a few points, that will look jagged rather than nice and smooth. Okay? So MATLAB and Matplotlib have always, by default, drawn a straight line between the points. Okay? You can make the line style be nothing. I'm pretty sure this works. So now when you run it and look at your plot, there is no line between it because you said the line style should be nothing. But by default, the line style is a dash, which is just a straight line. That's the default one. So you'll get straight lines. Okay?
When I'm using logical indexing, can I get it to return to me the indexes instead of just, like if I say where is labels equal to 0?
Right. Okay. So when you ask, if you give, if you have something like x is equal to, I'm going to import NumPy. Import NumPy as MP, x is equal NumPy dot array. 1, 2, 3, 4, 5, 6, 7, 8. And if you do give me the x's where x is greater than 4, right? And that gives you the values, and you're wanting to know the index positions. You need to use the NumPy where command, which is an analog to the MATLAB find command. So if I do NumPy where x greater than 4, and I can store that, maybe I'll store that in a thing called end. And so end says it's in the 0, 1, 2, 3, 4th, 5th, 6th, and 7th indices. Okay? Now, the weird thing about NumPy where is that it returns to you a tuple. You can see there's parentheses around it with a comma there. This is a tuple of length 1. Okay? So the type of end is a tuple, and the length of end is 1. So if you so you just have to if I do end 0, give me the first element in this tuple. Okay? That thing itself is a NumPy array. And then if you index that, say give me the second index, but third position, that will return the 6. So yes, you index it kind of like a two-dimensional array in C++, not in MATLAB. You have to have the double brackets. You can't do this. That doesn't work, you know. Okay, so yes, you index it like it's a double array. And the reason they have this is because when I did the end equals NumPy where, X could be a two-dimensional array. And if it's a two-dimensional array, then it's going to return to you the row and column where it is. So that tuple, the first element's going to be the row positions, the row indices, and the second thing in the tuple is going to be the column indices. But it always returns a tuple with them in. Okay? So a lot of times when I do this, when I do NumPy where on a 1D array, I often throw on the give me the 0th element. And now end is an array, not a tuple, because I've extracted out, I've taken that first level of the tuple away. So oftentimes when I do a NumPy where, I just throw on the bracket 0 and forget about the tuple stuff. And then I have a NumPy array that I can then index with a single index.
I was doing it with a for loop, going through every single and then separating it out.
Yeah, painful. So this is, I don't know, this is really weird. With NumPy especially, I find this sort of thing happening all the time where the functions return weird data types for me and you have to sort of sift through what is the data type and what does it mean. That's it's a little bit of a pet peeve of mine about NumPy, but there's so many other great things that I can see past it. All right? So yeah, that's how you find indices. Yes, question?
When it comes to can you show the plot for me?
Sure.
Is there a way, because it looks like you have an interval of 0.2 for each like X, Y, and Z. Is there a way you can expand it out to make it like an interval of maybe 0.1?
To make the grids tighter?
Or
to have the grids be tighter?
Yes.
Okay. Yes. That would be to change the ticks. And I've never done that in Matplotlib.
Because on the project, I have it where I guess they're signing up ticks in the graph, and everything seems a little bit compressed. I'm trying to expand it out.
Well, the ticks are only ever going to be how it looks and how many of these gray lines there are.
Yeah.
I mean, it's not going to change anything about the way the plot looks itself.
Okay.
So changing the ticks will just get you more gray lines.
Is there a way you can expand the plot so the points look more spaced out?
Make it bigger? I'm not sure what you mean.
I think he's saying instead of having it go from 0.8 to 1, having it to go from 0.8 to 2.5 plus 0.8.
Okay, to change the limits of the axis.
Yeah.
Okay. Yes. That I plot.xlim and we can have it go from, I don't remember, is it 2 integers or is it a tuple you're supposed to send? There we go. So, but a 2 to 4 wasn't a very good idea, was it? Let's go -4 to 4. So here I changed the limits to be bigger so they look squished together.
Mm-hmm.
Is that what you're looking for?
Yeah, I think that kind of answered my question. I just need to change the limits.
So the way I did that was with plot.xlim. Okay, and that will work for the x and the y. So let's do -4 to 4. I don't think that will work because that's the one I know works. Did I not run it? So there we go. Now I got the y lim -4 to 4. I don't think you can do the z lim. I think you need to use the 3D axis one. Yes, so there is none there. Let me see. Is there ax.z lim maybe? No.
There is
Let me see.
ax dot set _ z lim. You can do.
Okay. Set z, is it set z lim?
Yeah.
Okay. Set _ z lim like that? Yeah, there we go. Okay. So, and then there's probably an ax.set x lim too to make it consistent. You could do this. X.set x lim and ax set _ y lim.
So
Yeah.
now that everything's like compressed, we
Right.
just have to expand out the window itself.
Right, then you need to make the window bigger if you want to see that.
Okay.
So, I mean, the limits are set automatically to make whatever you plotted look as big as it can in the window that it has.
Okay.
So that's the way basically, if you don't set the limits, it'll just try to fit it as best as it can and make it as big as possible. So it tries to fill out the window as much as it can.
Yeah.
But then if you want to make it bigger, or if you aren't interested in all of the stuff that got plotted, you can make the limit smaller so that you're zoomed in on a part and you're ignoring some of the stuff that you plotted.
Okay. Because I had to set the limits in order to prevent it from being warped overall with the plots.
Right. Well, that idea was do the axis equal thing,
Yeah.
and then it won't be warped.
Yeah. And then it came into the point where just everything seemed so small.
Yeah, and it is. It is small. Especially it is small, and I absolutely. And when I created the images that I put in the description, I put the figure in full screen because there's so many details. I had to put it in full screen for me to get any reasonable way to see it. So I think that's probably the same thing you're running into, that if you have a window that's only a small portion of the screen, all the stuff is all in one little place down here. And that's just sort of because I've had to do that weird workaround for the axis equal. There's so much empty space in the figure that the stuff you actually want to see is in one small area in the figure. So yeah, maybe the answer for you is just to maximize your window and show it in the full screen.
Yeah, I think that's the answer.
Yeah. Okay. So what else is getting you guys tripped up?
I'll know more after the weekend for sure.
Okay. All right. Yeah, because this picture that I took, it was a full screen image. And you can see I did a bunch of photoshopping and I took away all the stuff that was up above here. So there's a whole bunch of stuff above that I just photoshopped out.
Oh, okay. Because I was trying to make it look like that.
You can't.
To be exact.
No. You need to Photoshop it to get it to do that. So I cheated. And it's just because there's no three-dimensional axis equal in Matplotlib. If they would do that, then we wouldn't have to worry about it. So you just want to work, and I'll come around and have a look at what you're doing, or?
I got a question. I was watching all the videos from 2610.
Yes.
And there was a way for your for loop to use different iterables.
Right.
Can you show me how to do that?
Yes. Okay, so that is kind of cool. Let me do this. Import numpy as np. X equals 2, 3, 6, 7, 9, etc. Then 4 element in X print element. Okay, so here's an example where a list is technically an iterable. Okay, and so I'm having a for loop go through X. And so each of the elements in X, in this iterable, are subsequently put in element. And the first element in this iterable is the list 1, 2, 3. The second iterable is the list 4, 5, 6. The third is 7, 8, 9, etc. And so each time through this loop, I'm getting one of the elements inside that list, which is kind of neat.
Wasn't there a way that you could do, like, you could have element and then you could have two things?
Yes.
And then it run through.
Yes, so I'm about to I was going to show you that one too. Yes. So I can do this. Let's set numpy.array. Let's try that. I'm going to print X just to see it. Let me just make sure I got what I want. Okay. Now, let's see. Yeah, all right. Now, for change its name. For X, Y, Z. Then I got another one on here. 10, 11, 12. X, Y, Z in data. Print X, Y, Z. Let's try that. Is that going to do what I think it's going to do? Yes. Okay. So, data is a two-dimensional array. It has 4 rows and 3 columns. And so I'm saying take the 3 things out of data. And the way this works is it looks at X is the column, these are the columns of the first thing in data. And so I'm pulling out the first column, second column, third column individually, and they're in individual variables. So if you have a two-dimensional array where every row is a new thing, a new sample, and the things across the columns are features or some other information, you can pull each of the columns into their own variables separately for each row in the array. So it's really interesting. And I know that there are a lot of other very fancy things you can do with the Python for loops that I've not become comfortable with yet, but this is sort of the first of what I've been able to see that you can do, and it's kind of neat. Yes?
Hey, so I have a question. I made a function to basically check if there's collision between rectangles.
Okay.
And I want to have if statements that check inside there if there's collision between two of those rectangles. And I have if this condition for collide is true, then it returns true.
The function is going to return true.
Yes. And then I just have it inside that if statement. And we'll have it at the end. Is that okay?
So you're asked. So you have a function. He's looking at the collisions, and you have an if statement in the middle of your middle of your function that's going to return true, and I'm pretty sure it works like C++. I know the way for sure it works in C++, and I'm pretty sure it's the same as Python, is that yes, as soon as it gets to the return statement, it will end that function and return that thing and move on. And in C++, you are forced to make sure that at some point in your function, that every path through the function hits a return. Because in C++, you have to return the same data type of no matter what. Okay? I think in Python it works the same way. So if you have an if statement, it'll just kick out early. But I think in Python, and maybe I can test this, I think that you can have a path that returns nothing and some paths that do return something. I think that is possible. Let me try that. So let's do def func x if x is greater than 5, return true. Okay, and so then if we do print func 10, that should return print 2. True. Okay? And I think if I do this, it just won't print anything. None. Does none. Okay? So this is something you can't do in C++. In C++, you have to ensure that every path through the program has a return, and it returns something of the correct data type. Okay? Here, you don't have, you can have some paths return something, and other paths not return anything. Okay? And if you don't return anything, and you ask the calling part of the function to do something with it, it'll just have the thing none, which is a variable value. I don't know if I suppose it's a class or something. So does that answer your question? Okay. So yeah, you can have returns anywhere you want in your function. I could do here, print not greater. So it'll do the print statement in this case, and it returns none.
Is there a break, kind of like C++?
I don't know, because at least the way I was trained, obviously to ask questions whether there's a break like in C++, I don't know, because I'm of the school of programming that breaks are one of the worst sins you can make in programming. That you only use a break when you can't figure out how to do it the right way. So I think so. I'm pretty sure there's some sort of break, but I will not encourage that. So if you want to use break, you have to find that yourself.
What's so wrong with break?
Because it upsets the flow of the program. The program is supposed to flow with control structures is supposed to dominate the flow, not a go-to statement or just give up. So I'm sorry, that is just my own personal style. But
coffee runs out and it's 5 a.m.
So I'm sure there is, Justin.
Is there a switch statement?
There's gotta be a switch statement. I personally don't like switch statements. I prefer if-else's, but there's gotta be a switch statement. I don't know. Maybe not.
I couldn't find
Maybe
it
there.
online, that's
Maybe
why.
there isn't. Yeah, that's true. You could use a dictionary. That is a fancy way to do it. Oh boy. A dictionary is it's in the Python primer if you really want to see, but it's basically a list where the elements in the list are not indexed by their numerical position, but by a label. So instead of saying give me the 0th element, I say give me the element with the name fun or whatever. And so you assign labels to each of the things in your list. So I don't know. Maybe it looks like there is no switch statement. Maybe they're like me, where they don't like them, and I just use an if-else or go with this fancy dictionary or something. At least the way the syntax is in C++, it's more cumbersome to me to do a switch statement than to just do if-else's. But that's, again, my own personal opinion. Other questions? Alright, well I think what I'll do now is I'll just go ahead and I'll stop the recording so there's not a bunch of dead space on here, and I'll just come around and look at your programs and see if you have any specific questions.